right? So hope you all have understood what are the characteristics of the analog low pass filter. And this you may expect as a theory question also. They will ask you to like explain about the characteristics of the analog low pass Butterworth filter. So with reference to that, today we will understand how to find the poles of transfer function. Then next we will decide how to find the order of the transfer function. Okay. So you just write the today's title as to determine, just write the today's title as to determine the poles of the transfer function. To determine the poles of H of S. The poles of H of S. Is my screen is visible?
No, sir.
No, sir. No, sir.
चलो एटलीस्ट इसके लिए तो रेस्पॉन्स देते हैं आप लोग. थैंक यू फॉर दैट. नाउ is it visible now?
Yes, sir. Visible.
Yes.
Okay. To determine the poles of H of S. So this is what the today's topic we are going to decide. So for designing a filter, we require the number of poles as well as we require the order. So based on that, we are designing this analog filter. Okay. As we have discussed already, the transfer function of the low pass Butterworth filter. The same thing we are taking here, and further we are just simplifying that. We just write one line. Hope you have noted the title. Have you written the title? To determine
Yes,
the poles of H of S. This sometimes you may expect as a theory question also. They will ask you to derive an expression how to find the poles of H of S for Butterworth filter. तो ये derivation आप expect कर सकते हैं exam में. So we will go with that part. Just write one line. The magnitude squared frequency response. The magnitude squared frequency response of the magnitude squared frequency response of the analog filter of the analog frequency response of the normalized analog filter. You just write normalized analog filter. So in bracket
Can
is
you take once again?
hello. Yes. Can you repeat again, madam? What do you want?
Yes, sir. Well, can you take once again this sentence?
Okay, okay. The magnitude squared frequency response. The magnitude squared frequency response of the analog normalized low pass filter, low pass Butterworth filter, that is omega c is equals to 1 radian per second. 1 radian per second is omega c equals to 1 radian per second is. So as already we have written this as a transfer function, magnitude h of j omega is equals to 1 divided by 1 plus omega divided by omega c to the power 2n and whole to the power 1 by 2. So this already we have seen in yesterday's lecture. Okay. Or this can also be written as magnitude h of j omega square, magnitude h of j omega square is equals to, this I can write it as 1 divided by 1 plus omega to the power 2n, since we are considering omega c equals to 1 radian per second. Okay, let us call it as equation 1. Have you understood this equation 1? Squaring on both the side I have done for the above equation, and I substituted the value of omega c equals to 1. Then it becomes 1 divided by 1 plus omega to the power 2n. Okay. Understood? Hello? Am I audible?
Yes, sir.
Okay. Now, you just write next line. Next line. Now, let us derive the transfer function. Now, let us derive the transfer function of a stable filter. Let us derive the transfer function of a stable filter. For this purpose, put omega equals to, for this purpose, put omega is equals to s by j in above equation. Put omega equals to s by j in above equation. Then above equation becomes, so what will happen here? So first we will solve for this left side part, then we will go for the right side part. So left side, what we are doing here is like magnitude h of j omega, this magnitude h of j omega square can also be written as h of omega square, which is equals to, I can write it as h into omega can be written as s by j square, or this is equals to, simply I can write it as h of minus s square it is. Can you understand this? Magnitude h of j omega square equals to h of omega square लिख सकते हैं. क्यों? हेलो,
j square is equal to -1.
j स्क्वायर इक्वल्स टू -1. अगर वो मैग्नीट्यूड से मैग्नीट्यूड वैल्यू है, उसके लिए अगर बाहर लिए तो इट इज गोइंग टू बी द पॉजिटिव वैल्यू वी आर राइटिंग. ठीक है, तो उसके लिए h ऑफ ओमेगा स्क्वायर लिख रहे. देन द दिस पार्ट आई एम जस्ट सब्स्टिट्यूटिंग s by j. 1 by j equals to what we can write 1 by j is equals to, क्या है उसका वैल्यू? One by j is what? Is equals to, we are going to write it as minus j. ठीक है, right? So then that becomes, or else simply instead of going this, how I can write is like s square divided by j square. ठीक है ना, s square divided by j square मतलब j square value is -1. So I can write it as simply minus s square, or this can be written as simply, this can be written as h of s multiplied with h of minus s. So this we are calling it as left half plane, and this we are calling it as the right half plane, right? So that means here this complete transfer function, we are dividing it to the two planes, like one is the transfer function on the left half of the plane and the transfer function on the right half of the plane. So therefore the above equation can be written as, I can write it as h of s is equals to, that is h of s into h of minus s, h of s into h of minus s is equals to, what we can write is 1 divided by 1 plus, here I am just substituting this value. So omega is again s by j to the power 2n, or this can be written as simply, this can be written as 1 divided by 1 plus minus s square, that is minus s square to the power n. Let us call it as equation 2. Let us call it as equation 2. Understood? Any difficulty here?
No, sir, no difficulty.
Okay. Just add one line after equation 2. The above relation tell us that hope you are writing it parallelly. लिख रहे हैं ना सब लोग?
Yes, sir.
Yes, sir.
Okay. The above relation tell us that this function has poles. This function has poles in the left half of S plane. This function has the poles in the left half of S plane. Left half of S plane. In bracket you write LHP. Left half of S plane. In bracket you write LHP, as well as in the right half of S plane. In the right half of S plane, that is RHP, you just write. That is RHP. Because of the presence of two factors, h of s and h of minus s, h of s and h of minus s, full stop. If h of s has roots, in the left half of the plane, if h of s has the roots in the left half of the plane, then h of minus s has the corresponding roots in the right half of the plane. That is RHP, you can write. Full stop. We can obtain these roots. By equating the denominator of equation 2 to 0. That is, we can write it as 1 plus minus s square to the power n is equals to 0. That is 1 plus minus s square to the power n equals to 0. The next line is just write, for n odd, Let us call this is equation 3. Equation 3 can be written as क्या लिख सकते हैं? Can anyone tell me if n is odd? Then what I can write for equation 3?
One minus s square is equal to 0.
1 minus s square equals to 0. Right. That means I can write simply. So this I can write it as 1 minus s square equals to 0, or else simply we are writing it as s to the power 2n is equals to 1. लिख सकते हैं? टू पाई के, दिस कैन बी रिटन एज e पावर j 2 पाई k, क्योंकि इसका वैल्यू और 1 हो जाता है. ठीक है. Let us call it as equation. We'll take it as a standard value as a. For n equals to odd, s to the power 2n is equals to 1, which equals to, we can write it as e to the power j 2 pi k. Okay. Now the roots of the equation 4, can be found as, sorry, the roots of the equation 3, right? The roots of the equation 3 can be found as, we can write here, यहाँ पे अगर आप equation 3 अगर if you are writing equation, what you are written, can you read that? Anybody? क्या लिखे अभी?
Roots of equation 3 can be found as.
Roots of equation 3 can be found as, roots of equation a you just write, instead of 3 you just write equation a, right? So this equation root we are finding. तो यहाँ पे क्या होगा अभी? So here I will just write it as this way. sk, here sk is equals to e to the power j pi k by n, e to the power j pi k by n. यहाँ पे ये 2 to get cancels and this n I am taking on this side. So it is sk is n even. What will happen? For n even, what will happen to the equation 3? क्या हो सकता? कोई बताएंगे मुझे? If n is even, तो उसको कैसा लिख सकते हैं? Yes? Anybody?
One plus s raised to 2n is equal to 0.
1 plus s raised to 2n equals to 0. So in that case, we can write it as simply s to the power 2n is equals to s to the power 2n is equals to -1 लिख सकते हैं इसको, बराबर. Just write here
Yes, sir.
for n even, just write it as for n even, for n even, equation 3 reduces to, for n even, equation 3 reduces to s to the power 2n equals to -1, or which equals to, simply we will write it as e power j 2k minus 1 into pi, which equals to, we can write it as e power j 2k minus 1 into pi, which gives the roots as, sk is equals to, which gives the roots as sk is equals to e power j 2k minus 1 into pi divided by 2n. sk equals to e power j 2k minus 1 into pi divided by 2n, for again k equals to, for k equals to 1, 2 up to 2n. Let us call this is equation 5. तो अभी हमने we are calculated for the value of n equals to the roots, and if the n is even, then we are calculated the roots. Now let us take one particular value, right? So if you take a particular value, have you noted this up to equation 5?
Yes, sir.
Any problem, any confusion here? किसी को कोई क्वेश्चन है यहाँ पे? Hello? Anybody is having any question here?
No, sir.
Okay. Then suppose for n equals to 3, if I am taking like n equals to 3, तब हम रूट्स का वैल्यू कैलकुलेट करेंगे अभी. फॉर n इक्वल्स टू 3, 3 मतलब क्या है? ऑड है क्या इवन फंक्शन है?
Odd.
यस, ऑड वैल्यू है. तो उसके लिए क्या होगा अभी? इक्वेशन अपना ये इक्वेशन ये क्या होगा अभी? फॉर n इक्वल्स टू 3, इक्वेशन ये बिकम्स, व्हाट विल हैपन? s to the power 6. ठीक है, फॉर n इक्वल्स टू 3, s to the power 2 है, तो x to the power 6 इज इक्वल्स टू 1. ठीक है, तो मतलब आपको अगर n इक्वल्स टू 3 है तो टोटल कितने रूट्स कैलकुलेट करने पड़ेंगे? यस, इफ द वैल्यू ऑफ n इज 3, देन हाउ मेनी रूट्स यू रिक्वायर?
6.
6 roots to be calculated, that is s to the power 6 equals to 1. So therefore, just write one line here. Therefore, for n odd, the roots can be obtained from equation. For n odd, the roots can be obtained from equation 4. From equation 4, क्या है अपना इक्वेशन यहाँ पे? sk is equals to, we have it is sk is equals to e power j pi k by n. Okay, so we'll calculate the first root. Let us call it as 1. s1 is equals to e power j pi by n. N is what? 3. So this is equals to, can you tell me the value of this? So first root we are calculating. S1 is equals to, कोई वैल्यू बताएंगे मुझे? What is the value of S1? So for your understanding, let me write here. So this can be written as cos pi by 3 plus j sin pi by 3. तो इसका वैल्यू कैलकुलेट करो अभी. So S1 is equals to 'Yes, anybody has got the value?
Point 5 plus J 0.866.
1 minute, let me write it. Point 5 plus
J 0.86.
0.5 plus j 0.866. कितने लोगों का आया वैल्यू है? How many?
Yes, sir.
How many of you have got this?
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay. Then similarly, can you calculate S2? Likewise, S2 का वैल्यू कैलकुलेट करना है मुझे. S2 कैसे कैलकुलेट करेंगे? Can anyone tell me? You have to calculate S2. You have to calculate S3. Total 6 values कैलकुलेट करना है हमें. S4, S5 and S6. We want to calculate all these values. Okay. S5 and then this is S6. Just calculate all the values and tell me the answer. Let's see. Yes, anybody has got the value of S2? S2 का वैल्यू कितना आ रहा है?
Minus 0.5 plus J 0.866.
It is minus 0.5 plus
J 0.866.
0.866. Hope everyone is understood. अगर किसी को कोई प्रॉब्लम है तो प्लीज आस्क. Here I have just substituted the value of k equals to 1, 2, 3, 4 5 आणि 6. n equals to किती व्हॅल्यू आहे आपलं 3. By substituting these values we are just calculating the roots. What about S3?
-1.
S3 S3 is -1.
-1.
Okay. S4
-0.5 minus J 0.866.
-0.5 minus J 0.866. ठीक है. Okay. Then
0.5 minus
0.5 minus
J866.
0.866.
0.5 minus J 0.866. Okay. And what about last one?
1.
1.
1.
1.
1. Okay. Now this is 1. Now what is the conclusion you can make out of these roots? क्या conclusion निकाल सकते हैं आप? Yes. What is the conclusion you can make out of this root? So if you look at into this part, S1 and, or else we will go with this first. So S2 or S4, how they are looking?
Complex conjugate.
Complex conjugate.
Complex conjugate of one another. ये दोनों complex conjugate of one another. और इसको तो ये constant term है, right? So that is S3 -1 and S6 +1. So by looking at this part, what we can understand is if we calculate first 3 roots, then further 3 roots will be the complex conjugate of the first 3 roots. Understood? Getting my point?
Yes, sir.
अगर ऐसा आ रहा है तो ही सही है, नहीं है तो somewhere we are doing the mistake that you can identify. ठीक है, ये पक्का ऐसा आना ही है, उसको complex conjugate value आना ही है. Yes, just write one line here. Just write one line. All the above poles are located. All the above poles are located. All the above poles are located in the S plane. In the S plane, as shown in figure. All the above poles are located in the S plane, as shown in figure. A, you just call it as figure A. Full stop. It is found that. It is found that the angular separation between. It is found that the angular separation between the poles. It is found that the angular separation between the poles is given by. Angular separation between the poles is given by 360 is given by 360 degree divided by 2n. 360 degree divided by 2n. 360 degree divided by 2n. So this you just make it as an underline, and you may expect this as a MCQ question. It is found that the angular separation between the poles, or the angular separation between the poles for Butterworth filter is given by 360 degree divided by 2n, comma, which in this case is equal to, कितना होता है अभी? What is the angular separation value now here? आपका n का वैल्यू 3 है, 360 डिग्री डिवाइडेड बाय 2 into 3, that is 6. 360 by 6, what is the value?
60 degree.
60 डिग्री. तो एंगुलर सेपरेशन आपका 60 डिग्री होगा. In this case is equal to 60 degree, is equal to 60 degree, and all the poles lie, and all the poles lie, L-I-E, lie on a unit circle. All the poles lie on unit circle. That is, so let us plot this. These all the routes we are plotting on the S plane. It is. तो यहाँ पे इसको हम S plane ऐसा plot कर रहे हैं अभी, right? So we are just plotting this way. This is the circle I am taking as a unit circle. Okay. So this I am writing it as j omega, and this is sigma. Normally we know that S equals to sigma plus j omega, right? So now we are dividing it into कितने इक्वल पार्ट में डिवाइड कर रहे हैं हम इसको? 6 इक्वल पार्ट में डिवाइड कर रहे हैं. ठीक है. सो दिस आई विल डू इट दिस वे, और ये हिसाब है. ठीक है. नाउ द पोल्स आर, वी आर टेकिंग इट फ्रॉम दिस पॉइंट. पोल्स का आइडेंटिफिकेशन कैसा रहता है? विद द क्रॉस पार्ट, राइट? द पोल्स आर रिप्रेजेंटेड विद द क्रॉस ऑलवेज, एंड the zeros are represented with what? Zeros को कैसा represent कर रहे हैं? Zero का representation क्या रहता है? Zero. The poles are represented by cross and zeros are represented by zero. ठीक है? Now, so this I am going to write it as S1, and this I am writing it as S2, and this is S3, and this is S4, and this is S5. Sorry, it is not at this point. यहाँ पे नहीं आएगा आपका पोल, will not be there. So this is at this point we are writing. This is S6, S4 के बाद S5, and then S6. So this is what the poles we are represented. ठीक है. और यहाँ पे सेपरेशन कितना है अभी? What is the angle separation?
60 degree.
Angle separation is 60 degree for this. ठीक है. तो अभी S1 का वैल्यू दिया हुआ है यहाँ पे. S1 is what? What is S1? S1 is like 0.5 plus J 0.866. मतलब दोनों वैल्यू फर्स्ट क्वाड्रेंट में आएंगे, बराबर? दोनों पॉजिटिव है. So this is our first quadrant, then second quadrant, then third and fourth quadrant. So as both are positive, so S1 is laying in the first quadrant. Then what about S2? S2 का क्या है? S2 value is, what about S2? It is sigma plus, hello, am I audible?
Yes, sir.
हाँ, अभी S2 का एक वैल्यू नेगेटिव है और एक वैल्यू पॉजिटिव है. मतलब यहाँ पे जे ओमेगा एक्सिस अगर आप वर्टिकली देखेंगे, ये साइड में सब पॉजिटिव आएंगे और ये साइड में सब नेगेटिव वैल्यू आएंगे. सो मतलब यहाँ पे लेट अस, आई एम अज्यूमिंग दैट इट हैज अ 0.5 एज अ पॉजिटिव वैल्यू. तो ये आपका 0.5 है यहाँ पे. तो यहां पे क्या आएगा, -0.5. गेटिंग माई पॉइंट. और ये वैल्यू क्या है आपका, सो व्हाट इज दिस, जे ओमेगा वैल्यू कितना है 0.866. तो ये यहां पे आता है. ठीक है. देन नेक्स्ट व्हाट इज S3. S3 का वैल्यू कितना अपना -1, मतलब यहां पे -1 आएगा. राइट. व्हाट अबाउट S4. S4 के वैल्यू दोनों नेगेटिव है, तो कहां पे आएगा वो, सो दिस इज अवर S4. सो S4 इज बोथ आर नेगेटिव, तो ये 0.5 और ये भी नेगेटिव है. सो इट इज S4 इज इक्वल टू, इट इज -0.5 माइनस J 0.866. ठीक है. व्हाट अबाउट S5. S5 का क्या वैल्यू, अगेन इट इज 0.5 माइनस J 0.866, and at the end S6 we have it is 1. So this is how we are plotting the poles, that is roots on the S plane. So this we are calling it as S plane. This is our S plane. और यहाँ पे, so this left half pole we are calling it as the poles of H of S. Poles of H of S is on the left half of S plane, and this is the poles of H of minus S. Poles of H of minus S, it is on the right half of the S plane. Okay, and let us call it as figure A. This is our figure A. Understood how the values are located, root values are located on the S plane?
Yes, sir.
Any difficulty in understanding this?
No, sir.
Okay, can I move further? Is
Yes,
everyone
sir.
noted this? बाकी लोग है क्या, चले गए? सिर्फ एक ही आवाज सुनाई दे रहा है.
Yes, sir.
ओके, सिर्फ यस सर बोल के एक ही आवाज सुनाई दे रहा है. मुझे लगा बाकी सब लोग चले गए, है ना उधर है? बाकी सब लोग है क्या उधर?
Yes, sir.
ओके,
हाँ सर.
Yes, sir. Yes, sir.
ठीक है, ठीक है. राइट, यू जस्ट राइट वन लाइन. द पोल्स आर डिस्ट्रीब्यूटेड. The poles are distributed on the unit circle. The poles are distributed on the unit circle. In the S plane, the poles are distributed on the unit circle. In the S plane, half on the left half plane, half on the left half plane, half on the left half plane, and half on the right half plane, and half on the right half plane, full stop, full stop. Since these are the poles of the product, since these are the poles of the product, H of S and H of minus S, H of S and H of minus S, poles of the product, H of S and H of minus S, and we want a transfer function, and we want a transfer function Hn of S. We want a transfer function Hn of S to be stable, that is we can write it as 1 divided by summation S minus Sk. 1 divided by summation S minus Sk. Let us call this as equation number. Number क्या है इसका? What is the number? Can anyone tell me the
Six.
number? 6 kya? Okay. Let us call it as equation 6. So Hn of s equals to 1 divided by summation s minus sk. A summation, are you getting this point? What is the indication of this? बड़ा पाई लिखा है मैंने, पाई का वैल्यू थोड़ा बड़ा साइज करके लिखा है, तो उसको समेशन बोल रहा हूं. तो अपना नॉर्मल समेशन और इसमें क्या डिफरेंस होगा? Or else this equals to, they are writing it as like this is equals to 1 divided by, मैं बताता हूं आपको क्या डिफरेंस होगा अभी, bn of s, 1 divided by bn of s. You just add one line there, where sk, where sk, all the left half poles of Hn of s, where sk are all the left half poles, left half poles of Hn of s, left half poles of Hn of s, and Hn of minus s, Hn of minus s, and Bn of s is, and Bn of s is, Bn of s is the Butterworth polynomial, Butterworth polynomial, Butterworth polynomial of the order n, Butterworth polynomial of the order n. तो क्या मतलब है इसका अभी? All the left half poles of Hn of s and Hn of minus s, मतलब अभी जो ये ट्रांसफर फंक्शन है आपका, so left half poles मतलब only the poles which are lying on the left half, so मतलब ये यहां से इधर वाले, तो क्या क्या poles है अभी? s2, s3 and s4. So you have to remember one condition again, for the system to be stable, all the poles should lie on the left half of the s plane, so that you may expect as a MCQ again. For the system to be stable, all the poles should lie on the left half of the s plane. Just add one more line to ensure stability, to ensure stability, to ensure stability, and considering only the poles, to ensure stability, and considering only the poles that lie in the left half of the s plane, poles that lie in the left half of the s plane, full stop, we can write the denominator of the transfer function h of s as, we can write the denominator of the transfer function h of s as, क्या लिख सकते हैं अभी? कोई बताएंगे मुझे? Denominator of the transfer function can be written as, कैसा लिख सकते हैं denominator उसका? Anybody? Can you try to answer that? Hn of s is equals to, I can write it as Hn of s is equals to, or simply we can write generally h of s is equals to 1 divided by, left half of the poles means what? S minus s2, s minus s2, then s minus s3, और एक s minus s4. Getting my point? So therefore h of s equals to, we can write it as, therefore we can write the denominator of the transfer function h of s as, h of s equals to 1 divided by s minus s2, s minus s3 and s minus s4. Now this becomes, this is equals to, यहाँ पे values you just substitute for all. So I have understood this. How I have written h of s?
Yes,
हेलो,
sir.
दिस एच ऑफ एस इक्वल्स टू 1 डिवाइड, मतलब ओनली लेफ्ट हाफ पोल्स हम कंसिडर कर रहे हैं अभी, ठीक है, इतने पोल्स कंसिडर कर रहे हैं. सो टू अंडरस्टैंड द स्टेबिलिटी ऑफ द सिस्टम, नाउ लेट अस सिंप्लीफाई दिस and we'll write that finally the expression. So h of s equals to, I can write it as h of s is equals to 1 divided by s minus s2. वैल्यू क्या है अभी s2 का? s minus of minus 0.5 plus j 0.866. Okay, this is the first term. Then what about second? S3 value is how much?
minus 1.
माइनस 1 है तो यहाँ पे क्या आएगा? s plus 1 आएगा अभी, सेकेंड टर्म. एंड थर्ड टर्म इज s minus of minus 0.5 प्लस आएगा या माइनस आएगा? ये
Minus.
S4 का वैल्यू कितना आपका? माइनस है, सो माइनस j 0.866. तो यहाँ पे सबका वैल्यू सब्स्टिट्यूट किया मैंने, और एल्स इफ यू सिंप्लीफाई दिस विल गेट इट एज 1 डिवाइडेड बाय s plus 1. s plus 1 को ऐसा जैसा वैसा ले लेते, मल्टीप्लाइड बाय, वी कैन राइट इट इज s plus 0.5 स्क्वायर. इसको आपको जैसा चाहिए वैसा सिंप्लीफाई कर लो, प्लस 0.866 स्क्वायर, और फाइनली आई कैन राइट इट एज 1 डिवाइडेड बाय s plus 1 divided by s plus 1 into s square plus s plus 1. So this is our final transfer function. h of s is equals to, this is the final transfer function for, अभी order क्या है इसका? What is the order? Order of the transfer function, can anyone tell me?
3.
3 it is, क्योंकि यहाँ पे s square और यहाँ पे s है, and we have derived it for n equals to 3, right? So this is how the transfer function we are calculating for this Butterworth low pass filter for the order n equals to 3. Poles and transfer function, we can say it. Hope you understood this, right? So we will stop it here. Further, we will continue again in the next class. And today's absent numbers are roll number 23. Absent numbers I am just calling. Roll number 25, just check. Roll number 30, roll number 34, 38, 40, 48, 55, 59, 60. Santosh Khilare. Santosh Khilare is there? 62, 63 and 65. So these are the absent numbers today. किसी का रह गया है क्या? Okay. Shall I close here? Hello?
Yes, sir.
Okay.
Yes, sir.
We'll close the session here. Thank you. We'll continue again.